So if you're watching this on YouTube later, this is chapter 40 that we're doing in my new book, Overcoming ACT Math by Sophia Garcia. It's available on Amazon, and it's the Matrices chapter. So really quick, before we start this, I wanted to let the first 7 people that bought this book, there were just very few typos in it, and one of them is number 8. So I just wanted to go to number 8 to show you how I changed the question. Let me see, number 8. What was it? I don't even remember how I changed it. Hold on, let me look it up on my computer really quick. Because this is the first book thing. Give me 1 second, guys. What did I do to the matrices number 8? Matrices number 8. How did I change it? I said 4. Oh, I changed this to a 4. This is a 4, and this is a -8, this is a 0, and I said this is equal to, and this becomes 8. Yeah. And then all of these answer choices remain the same. It's just I accidentally flipped those. So just remember that when you're doing it, if you're one of those 7 people with the book. Now, the other thing I want to remind you guys of is when you are multiplying with matrices, the way that you need to be talking about these matrices is rows times columns. So the number of rows times the number of columns. So, for example, if I am multiplying these matrices, this is a 2 rows by 2 columns matrices. So I would say that's a 2 by 2 matrices. And then this one is a 2 rows by 2 columns matrices as well. So if I'm doing B times C, I would say that I'm doing a 2 by 2 times 2 by 2, rows times rows, I meant to put rows times columns in parentheses like that for each of the matrices. And the reason that this is important is because it tells us what we're going to end up with for our final answer, what type of matrices we end up with, and if we can multiply these. So we know if we can multiply these because the answer, yeah, I know. Sometimes I say matrices and matrix and I mess up the plural and everything like that. Whatever. We know what I'm talking about. So then we have the 2's cancel out right here in the middle. So that's when you can multiply them. When these 2 numbers are the same, they cancel out, and we can get that this is going to be a 2 by 2 matrices because you just leave the outside numbers. Now, an example of where you could not do that is, let's say you have a 2 by 1 and a 2 by 2 matrices. 1 and 2 are not the same number, so these do not cancel out, so you could not multiply these. Now, you could also have something let's say 2 by 2 times 2 by 3. These you could multiply because the middles cancel out, but the answer is going to be 2 by 3 because there's a 2 times 3 left on the outside. So that's why it's important to remember this for multiplying matrices. Basically, for adding matrices, you just line up the positions and add or subtract them. So for instance, with number 1, we're subtracting between these. So all I have to do is match up the positions. 3 and -9 are in the top left. So I'm going to subtract those. 3 minus -9, and that's going to be what's in my new position on the top left. So if you want, some students find it easier to put the blanks for how many spaces you need. This is the top left, and then you need a top right, you need a bottom left and a bottom right. So that's how I'm going to do it, just to show it visually. But that's all you do. You just match up the places and subtract or add whatever they're saying. In this case, the subtraction. So the top right one for my answer is going to be top right B, -5, minus the top right here, 6. So -5 minus 6. And then I'm going to do bottom left minus bottom left. So that's going to be -4 minus 2. And remember, you always need to go in the order that it says. So B minus C, I'm starting with the B because that's what they say to start with. So that's just another thing to be aware of. So -4 minus 2. And then for bottom right, it's just going to be the bottom right 9 minus 3. So then you just have to simplify it. So minus and minus is plus, so this is going to be 12. And then -4 minus 2 is -6. -5 minus 6 is -11. 9 minus 3 is going to be +6. So then that is just going to be A right over here. So for this one, again, it's just the same thing. You just match up the positions for plus and minus, and you just like do whatever it says, plus or minus. So I'm going to put a line for my top left, for my bottom left, for my top right numbers, and for my bottom right numbers. And I'm going to say, okay, I'm going to add these up, b plus c, so it's going to be 3, top left, 3 plus negative 9. And then I'm going to do this one right here, top right, so negative 5 plus 6. Bottom left is going to be negative 4 plus 2. Bottom right is going to be 9 plus 3. And then I just need to like solve that. So 3 plus negative 9 is going to be, sorry, I'm a little OCD, so that's going to be negative 6. And then negative 2, because negative 4 plus 2 is negative 2. Negative 5 plus 6 is going to be 1. And then 9 plus 3 is going to be 12. So then this would be H right over there. So then we're going to do some that aren't the same dimensions as well. So let's go to this one right here. It says, for matrices B and C shown below, which of the following matrices represents B minus 3C? So for this one, it's basically before you start matching the places, like we did on the previous problems, you have to first distribute a 3 to each of the numbers. So it's going to be 3C, so that means that you have to multiply each of these in C by 3 before you do the subtraction. So you have the B one, let's just copy that over, 3, negative 4, negative 5, 9. This is the B matrix. And then we're going to subtract 3C, which is just 3 times each of these numbers right here. So it's going to be minus 3 times negative 9 is negative 27. 3 times 2 is 6. 3 times 6 is 18. 3 times 3 is 9. And now you just do the thing where you match up the places. So I'm going to put a place for the top left, bottom left, top right, bottom right. And so top left, I'm just going to subtract the top left one. So 3 minus negative 27. And then I have the top right one, so negative 5 minus 18. Again, I'm just matching up top left, or top right, sorry. Now, to find the bottom left one, I'm going to match those up, negative 4 minus 6. And to find the bottom right one, I'm going to say that I'm matching up the bottom right, so 9 minus 9. So 3 minus negative 27, that just turns into a plus, so it's going to be 30. And then negative 4 minus 6 is going to be negative 10. Negative 5 minus 18 is negative 23. And 9 minus 9 is 0. So this is going to be, that's A, right over here. So now here we have for matrices B and C shown, which of the following represents BC. So the reason there's a cannot be determined here is because we have to first check if we can even multiply these, like I was saying at the beginning of the video. We have to think in rows times columns and rows times columns. So for B, it's going to be 2 rows times 2 columns, so it's a 2 by 2. And C, it's going to be 2 rows by 3 columns, so it's a 2 by 3. Now, you know if you can multiply these if the middle, the inner numbers are the same, so they cancel out, which they are, so that means you can multiply them, and it tells you what type of matrix you're going to get as your answer with the numbers that are left over. So the numbers that are left over are 2 by 3, so that means we have 2 rows and 3 columns for the resulting matrix. So that's what I'm going to do. I'm going to put like little spaces for that. So 2 rows and 3 columns. So now what you're going to do is, oh, that's not going to be a lot of room. Let me actually get out a different sheet of paper for this so that it doesn't get so messy. So we want a 2 by 3. So just adjust this. So we want a 2 by 3. 2 by 3. Yeah, we're going to make this, hopefully this will fit. Because it's not going to fit in the camera otherwise. So a 2 by 3. And then we're going to say, okay, when we're multiplying, we're basically going to multiply, like, think about it like, I'm trying to think of the best way to, like, describe it. So this is going to be the first row, first column one. Like, this space is in the first row, first column. So that's what you're multiplying, basically. You're multiplying the first row times the first column because of the position here. So it would be the first row, 3 and negative 5 times these numbers right here. So it would be 3 times negative 9. And then you just add it to negative 5 times 2. And then that's going to be what goes there. And then this one is in the first row but second column. So that's what you're going to be multiplying to and adding together. So it's going to be the first row, the 3 and the negative 5, times the second column, the 6 and 3. So it's going to be 3 times 6 plus, and that's going to be negative 5 times 3. And then this one's going to be first row, third column. So you're going to do the first row, 3 and negative 5 times this part right here, the third column. So it's going to be 3 times negative 1, and that would just be 3 times negative 1 plus negative 5 times 1. And then you do the same thing with the bottom parts, except it's going to be like what the position is. So like this space is the position of second row, first column. So that's what you're going to be multiplying and adding together. So it's going to be the second row, negative 4 and 9, and you're going to be multiplying it by the first column right here, the negative 9 and 2. So it's going to be negative 4 times negative 9, and you're going to add that to 9 times 2. Now for this one, this is the space that's the second row, second column. So you have to do the second row, negative 4 and 9, times the second column, 6 and 3. So negative 4 times 6 plus 9 times 3. So now this is going to be the second row, third column. So you have to do the second row right here, negative 4 and 9, being multiplied by the numbers in the third column right here, negative 1 and 1. So it's going to be negative 4 times negative 1 plus 9 times 1. And then now you just have to like do the actual math to find what number goes in each place. So this is going to be negative 27 minus negative 27 minus 10. So that's going to be negative 37. And I'm going to do this one next. So negative 4 times negative 9 is 36 plus 18. 36 plus 18 is going to be 54. And then we have 3 times 6 is 18, plus negative 5 times 3 is negative 15. So 18 plus negative 15 is going to be positive 3. And then here we have negative 24 plus 27. So that's going to be positive 3 as well. And then we have over here negative 3 plus negative 5, which is going to be negative 8. And then negative 4 times negative 1 is positive 4, plus that's 9 times 1, which is going to be 9. So 4 plus 9 is 13. So then let's look for that answer basically in the answer choices. So that's going to be 37. That's J, right over there. So let's now go to this one right here. So it says that we have these being multiplied. So remember, you have to think rows times columns for what type of matrix it is. So this is a 1 row times 2 columns times a 2 rows times 1 column. So the middle numbers cancel out. So, and they leave us with a 1 by 1 row by 1 column matrix. So in my answer, I basically just have like one number that I'm looking for, like 1 row, 1 column, but you could like write it if it makes you feel better like this. And basically you would do, it's going to be 2 times 3 and then negative 2 times 2 right over there, because you're doing the first row times the first column, because technically this space is in the first row, first column. So it's the same concept that we were doing here, just like simpler because we have less stuff to work with. So it's going to be 2 times 3 plus negative 2 times 2. So then we would do that's 6 plus negative 4. So that's just going to be positive 2. So it would be C right there. So let's go to number 6. It says, which of the following expressions rewrites this to solve m in terms of n? So when you see these, they kind of look like absolute value bars, but they're something called looking for the determinant. And what that means is basically when you see these, you know that, or you're being asked like explicitly, find the determinant, like they mean the same thing. This means that we can find the determinant, which is just basically you multiply. It's kind of like cross multiplying in a way where you multiply diagonally and subtract. So it's going to be like 6m minus the other diagonal multiplied minus 3n, and that has to equal 18 is what that's saying. So we want to just solve for m in terms of n. So we're trying to get m by itself like it is in the answer choices. So I just need to isolate m by moving everything away. So I'm going to add 3n to each side. So then I'm going to get 18 plus 3n is equal to 6m. Then I'm going to divide by 6 on each side to get m completely by itself. So then that would be 18 divided by 6 plus 3, 6n. So then I just have to simplify this. So 18 divided by 6 is 3, plus this is just 1/2 n. So that would be the same thing as 0.5, so it would be k. Someone asked why minus, because it's just a thing that we learned in math. It's called looking for the determinant. Whenever you see these bars, or like they might explicitly ask you find the determinant for yada yada, like these bars or like stating that means find the determinant, and that's how you find the determinant. You just have to memorize that basically you multiply and subtract the diagonals. So you start with the top left diagonal and you multiply those and subtract the other diagonal. Yeah, everyone always comments on my pen. It's the, honestly, I should be sponsored. I'm selling so many of these pens. Papermate Inkjoy Gel 0.7. So then let's go to number 7. Based on the table shown below, which of the following products is not possible? Assume M, P, and Q are positive integers. So we want what's not possible. And these are basically talking about multiplying matrices together. So remember, when you multiply, you have to think rows times columns, and then times rows times how many columns there are in the matrices that you're talking about. Now, be careful because the left has the columns here and the right has the rows right here. So we have to just be aware of that. So when we're talking about matrix A, its dimensions are going to be Q rows times P columns. So A is Q rows times P columns, and it's being multiplied by matrix B, which has P rows times Q columns. So remember, we're looking for what's not possible. Not possible. So if we can cancel out the terms in the middle, which we can if they're the same, it is possible to do that multiplication. So we don't have A as one of our options. So let's go now to AC. So rows times columns would be not 9. Q rows times P columns times, and then for C, it's going to be P rows times M columns. And you see how the P's cancel out there, so this is possible. So then for AD, it's going to be, again, Q rows times P columns times, and then it's going to be, for D, it's going to be P rows times P columns, so then these cancel out. Yeah, the P's and the Q's, yeah, are, like, really annoying with, like, M and N do that to me, too. Like, and U and V, when stuff, like, but I feel like they do that on purpose, which is why I did that, just to, like, help make sure that people, like, were aware of that. So then it could be, like, we could multiply that, so it is possible. We're looking for what's not possible. So then let's go to C. So with C, it says that we have P rows times M columns, and we would multiply by, A says we have Q rows times P columns. Now remember, it has to be the same on the inside to cancel out for us to be able to multiply that. These do not cancel out. M cannot cancel out Q. They're not the same, so this is not possible, which is what we were looking for, so D. So let's go to number 8. It says, what's the value of Y for this one? And I rewrote it because I accidentally, someone just said that, like, they think they have dyslexia. I think I have dyscalculia because this only happens to me in, like, math, where, like, I'll flip numbers and stuff, like, so much. And, like, I did that here, so that's why this is 4 and that's 8. So then what we're going to do now is, let me see. So we have this times this equals that. So basically you're just going to do the first row times the first column right here. So it's going to be, first row times first column would be 4x plus 0y. And that's going to be what goes there in the first row, first column one. And then this is going to be second row, first column. And you could have done like the thing where you say, oh, this is a 2 by 2, 2 rows times 2 columns, and this is a 2 rows by 1 column. That's how I knew, like, how you could know that the spaces are there, because these cancel out and you get a 2 by 1. But then I saw, like, if you see it set up like this, where this is already a 2 by 1, you don't have to really do that step. But if you want to, you could, just to, like, know how you're going to set it up. But I saw that this was already a 2 by 1, so I just, like, kind of skipped that part. But I realized some people might not see that, so I'm just showing you there. And now this one is going to be the second row, first column. So that means you have to multiply the second row numbers times the first column stuff. So it's going to be, and add them up. So it's going to be 24 times x, 24x, plus negative 8y. And then we said that that's going to all equal 8 in the first row, first column space, and negative 64 in the second row, first column space. So this is saying first row, first column has to equal this first row, first column, basically. So 4x, because 0 cancels out, 4x has to equal 8. And then we could solve for x by dividing by 4 on each side. So then we get that that's equal to 2. And then we have, in the second part, it says 24x minus, because plus a negative is just minus, so minus 8y equals the other number that's in the second row, first column, so equals negative 64. Now, since we know that x is equal to 2, and this is supposed to be 24x, sorry. Since we know this is equal to 2, we could plug that in for x, and we could say 24 times 2 minus 8y is equal to negative 64. And then 24 times 2, that's going to be 48. So 48 minus 8y is equal to negative 64. Thank you guys for all the support. I really appreciate the likes. So then let's go and subtract 48 from each side. So I'm just kind of running out of room, so I'm going to go put that down here. So negative 8y is equal to, that's going to be negative, is that negative 112? Yeah, negative 112. And then we're going to divide by negative 8 on each side to get y by itself. So when we divide by negative 8, that's going to be y is equal to 14. So we're being asked for the value of y, so that's what we got for y, so it would be j. Now, I put like throughout this book sometimes bonus questions if like I think that there's something you could do in like 30 seconds or something. That could be like another way they ask the problem, or like something good to just review. So like for this one, sometimes they might ask you to give the answer in terms of like an ordered pair solution. And that just means like as a point, x comma y basically. So you know what the x and y are, you could just rewrite it as an x comma y point, because you know x is 2. And then y is 14. So like some of the answer choices, like they might have just instead asked you what's the ordered pair, or like what are the coordinates for the points that match this, basically, something like that. And they would just give you a bunch of points in the answer choices, and that might be a way that they ask this type of question too.